All right, looking at question 8 here, I have these three equations at the top, 1, 2, and 3, and I want to use them to build that bottom equation. All right, I'm not going to worry at first about these O2s, and that's mainly because I find them in two equations. They're both in equation 2 and equation 1. But everything else is isolated. So what I mean by isolated, I want that as a highlighter. The NO and the NO2 are only found in equation 3. And the atomic oxygen, the O by itself, is only found in equation 2. So I'm going to actually manipulate equation 2 so I get those reagents exactly where they are in the overall equation. And that does mean I'm just going to take equation 3 and write it just like it is, because it has exactly what we want. It's got a single NO as a reactant. Not worried about the O3 yet. And a single NO2 as a product. And I'm not worrying about that O2 there yet. That's in equation 3. All right. In equation 2, that has the atomic oxygen, the O that's by itself, it has a 2 there. I want it to be a 1, so I'm going to multiply all those coefficients by 1/2. So instead I have half of an O2 gas producing just a single O gas. Alright, if I combine things now, I see something interesting. This half of an O2 is going to cancel half of this. So I'd have half of an O2 down here. I would have an NO2. And the other thing I have is that atomic oxygen. On the reactant side, I have just the NO gas and the O3 gas. Now, if I look at that compared to what I call this overall reaction, I have O3 when I don't want it, and I have O2 on the product side that I don't want. Alright, so I'm going to take care of this O3. I'm going to cancel it out by making sure I make another reagent that has just a single O3 as a product. That's where I'm going to use equation 1, because it's the only equation that has that O3 in it. So I'm going to do a couple things. I'm going to write equation 1 backwards, so it has the O3 as a product. It was a reactant above. And I'm going to multiply all those coefficients by 1/2, so that 2 goes away. So that means that this 3 becomes a 3/2, and O2 is now a reactant. Alright, but when I combine those two equations, the bottom two, the O3 cancels out, and 3/2 of an oxygen cancel out that 1/2 of the oxygen, leaving just one oxygen, giving a new overall equation of the NO gas, a single O2 gas, gives us the NO2 gas and a single atomic oxygen, which matches our overall equation. Alright, so that means these three manipulations of our equation can allow us to combine these equations. So we are going to be able to just add these up to get our new delta H, but I have to repeat what I did here. So equation 3, I'm not doing anything because I didn't do anything to equation 3. But since I multiplied all the coefficients in equation 2 by 1/2, I'm also going to multiply this by 1/2. I did the same thing on equation 1, so I'm multiplying it by 1/2. But since I reversed it, I'm flipping the sign of this. So when I add these up, I'm going to do 427 times 1/2 plus 495 times 1/2 minus 199. And I get a delta H for that new overall equation of 262 kilojoules.